Hi everyone, welcome to this session about technical debt, dedicated to technical debt, which is titled "You Might Be Studying Technical Debt and Not Know It." I'm Antonio Martini, I'm Associate Professor at the University of Oslo. I was General Chair of Tech Debt 2021, which was a co-located event at ICSE last week. Tech debt has been growing for 10 years now. So technical debt research has been going on for quite a while, I would say. Technical debt is not just a metaphor. We actually can see that it's a phenomenon that is actually going on in research, in practice in industry quite a lot. And software industry has to deal with it every day. And we have also some experience here today. The idea of this short event is to basically take the opportunity to discuss this topic with some fellow researchers, also from other subdomains at ICSE. So I hope we have some represented here today. We definitely have some in this panel with our three, let's call them panelists. Yes, and the idea is that we have noticed that there are some papers actually that have been published at ICSE about technical debt. Some papers actually that, they discuss technical debt, they study technical debt, but they don't explicitly mention this. And also the important thing is that technical debt is a very interdisciplinary field. And most of the work so far has been done, in basically also looking at the code, crawling code, but technical debt, it's much more than that. So we should study other aspects like human factors, the security, aspects of technical debt, something that has been called security debt last week, for example. There are new domains in which we can get technical debt like AI and so on and so forth. And also we believe that maybe researchers from other aspects related to technical debt can also bring in additional research methods, validation that can boost technical debt research, and vice versa, we can contribute to other research fields from the technical debt community. So this is an opportunity to have this discussion a bit cross-disciplinary. We have three panelists with us today. Caroline Simon from University of Maryland, Ipek Oskalia from the Software Engineering Institute, and Erin Woods from Endava, which is a software engineering and service company. So also from the trenches, from the actual practice. So this is a really good opportunity to discuss this. I have some questions that I'm going to ask the panelists, but it would be very nice if also from the audience you have questions. It's a good opportunity to ask, clarification or even, brainstorm ideas with our panelists here. So I will be monitoring the chat and ask your questions to the panelists. So I welcome all our panelists now. And the first question is, please, could you introduce yourself, tell us who you are, and how you discovered that you were studying or dealing with technical debt? Maybe Caroline, you can start.
Okay, I'll start. Hi, everybody. My name is Caroline Seaman. I'm a professor of information systems at UMBC, which is in Baltimore in the state of Maryland in USA, otherwise known as Cicada Central right now. We have an infestation that maybe you've heard of. But so I have been doing tech debt research for probably 12 or 13 years. I was first introduced to the topic. I was in a meeting with developers from at the time, an industrial partner that I was doing a study with. The study we were doing didn't really have a whole lot to do with technical debt. It was about software process management and software process improvement. But we got talking about managing big systems as they age. And one of the developers in the room said, started throwing around this term technical debt. So I said, sorry, please tell me, what is this thing called technical debt? So they explained it to me. They started pulling out, TD also stands for to-do list, evidently, because they would pull out their pieces of paper from under their keyboards with all the things that they would needed to do to fix up the code and things that they didn't have time for before. So when they had time, they would go back and do these things. And that was their TD list, AKA technical debt list. So that's how I got introduced to the idea. And yes, it's I've done research in software metrics, software management, software maintenance, and these all sort of came together in this really nice, neat metaphor that is very meaningful to both researchers and practitioners, called technical debt. So at that point, I guess I became a technical debt researcher. Thanks.
Thanks a lot, Caroline. Erin, I think you had, would you like to share your experience?
Sure, thank you, and thanks for the invitation. I'm Owen Woods. I'm the CTO at a company called Indaba, as Antonio mentioned. It's about 8,000 people doing software engineering for other people. How did I get into technical debt? Well, we were joking beforehand that I've been creating technical debt myself since I started developing software in about 1990. Probably when I was playing around at home before that, but it's been something of direct interest for at least the last 15, probably 20 years, because I've been technical lead and architect, and technical debt is what slows you down and prevents you doing things. So I've been very keen on managing it, and I've been following industrial work in it. And then when I became more interested in the research field 7, 8, 10 years ago, it was something that I was very interested in following. So I gave one of the first keynotes on it at the technical debt conferences, and I've been sort of tracking you all. I've been lurking and stalking the technical debt researchers ever since.
Yes, thanks a lot, Erin. Ipek?
Thanks a lot for the invitation, Antonio. Ipek Özkaya with Carnegie Mellon Software Engineering Institute. I stumbled upon technical debt around 2008. And at the time, a couple years into my tenure at the Software Engineering Institute, I had secured a research project which was called Economics-Driven Architecting. The essence of that was, if you don't do the architecting thoughts and decisions early enough, you will actually have to do rework. Can we actually describe that rework so people paid more attention to it, both in terms of short-term and long-term? As I was discussing with a colleague, I was very excited. Jeremy Carriera, who's I think at Facebook at this time, he was at Vistaprint, then moved to Google. So he's a very hands-on and knowledgeable software architect. He said, Ipek, you know what? You're onto something, and people are actually calling it technical debt. This was about a year after Martin Fowler and Steve McConnell had published their blog posts that everybody actually refers to. So that's how we came into it. Around 2010, we thought, you know what? Is there actually something there, or are we reinventing the wheel? Carolyn was there. We actually had a small workshop at the Software Engineering Institute where we brought people, we talked about it, and there was a small paper that came out of it, a 4-pager at an FSC workshop, and then the rest is history from a research perspective. So, and SCI is a different institute organization. It's both research, but it's also customer work as well. We work with industry and government customers, and there's a ton of technical debt in the systems created. So that's been our journey. Thanks
a lot, Ipek and everyone in the panel. We have a question actually from the audience, which seems to have been reading my mind, because it's very similar to what I wanted to ask you. So yes, we have done like 10 years of research on technical debt, but there are still probably some topics that are very important and we haven't solved yet. And also keeping in mind like this interdisciplinary about technical debt, what is that we are still missing, what we need to deeply investigate? What are your thoughts? We can start with maybe reverse order. Maybe Ipek, you want to start?
Sure. So I think we actually haven't solved much yet. I think we've increased visibility. People know when you say technical debt, people are starting to believe, okay, they're right. We're believers now. We need to manage it. Now what? I think that's where we are, which we've done a great job. And it took a while because there was always, this is a cute metaphor. You can't necessarily do much with a cute metaphor. Are there practices? Are there not practices? Can we actually agree upon a definition? I think that process, and I haven't looked at other research domains, but that evolution probably is needed in both from a practical perspective as well as a research perspective. But I feel there's still a lot to be done. First of all, a consistent practice still is non-existent. Even if we get organizations, developers to consistently track their technical debt, make it visible, talk about it, that's a win. And I think all the other empirical practices in terms of measurement and all of that that people really want will come out of that. So maybe I'll stop here so that I also get to hear from Carolyn and Owen.
Yes, Owen, maybe you can go next.
I completely agree, Ipek. Nothing's been solved. Yeah. Maybe there have been, to a first approximation, maybe there are little bits that I'm unaware of. But Ipek's book, actually, which is being too modest to mention, on managing technical debt, which she's the co-author with Rod Nord and Philippe Crichton, that's the best overall reference I know to how to manage technical debt. But again, it's got 6 principles, which are all very sensible. And it's about making things visible and working on it regularly and trying to understand it and manage it. But actually, a lot of it is good practice, and industry's also got ideas around good practice. But what researchers, of course, do is they state hypotheses and look for evidence to support the hypotheses. And that bit, I think we're really missing as to which practices work. I also think that the practices we use in industry are almost painfully simple, maybe because those are the ones that start at the grassroots and are easy to spread. But there must be more sophisticated ways of technical and management ways of dealing with it. So I think there's a lot to do. One caution is, as I read papers for the Tech Debt Conference, I see a repeated pattern, which I think is a mistake, although I understand what happens, which is to do empirical work on GitHub and generalize that to the world. Now, the kind of systems that I deal with every day in large client systems, never mind the huge systems that people at Ipek deal with through the SEI, they're very, very different in character to what you find on GitHub. And they're also, they exist in a very, very different environment to most open source projects. So I think it's partly industry's fault, it's not being more proactive and offering up their code bases for analysis. But also, I've never personally been asked that. I'm not sure if I could give it, but I've never been asked it. So I'm not sure that either side is thinking about how to actually do the empirical work. And I'll stop there. Talked too much already.
Yes, very nice. That was great. Caroline, what do you think?
Yeah, so I'd agree with what both Ipek and Owen said. But to me, the piece that's missing that I think we're ready to start addressing, even though we haven't solved all the problems at the ground level, but where TD research to me needs to be heading and need to be thinking about is decision making. So a lot of the work that we saw at Tech Debt last week, a lot of the papers we see on Tech Debt here this week at ICSE are still about identifying technical debt and characterizing it and measuring it and figuring out how to talk about how much there is and where it is. And that's all good. But the next step is to make decisions about it, what to do about it, what should the strategy be, how do you prioritize, because there's always more technical debt that you can actually address. What are the strategies for prioritizing it? What are the strategies for addressing it in concert with other work that's going on? How do you manage the backlog of technical debt? How do you make decisions? And one thing I really like about focusing on that area is other people have, in other areas, have done a lot of work on decision making. So there's a whole decision sciences field there, and there's a field of economic decision making. There's work in information systems and other areas about decision making, especially decision making in the context of uncertainty, which is certainly the context we have with technical debt. And it's not impossible, but there are ways to do it. And I think that's really the big research question or research area that TD research needs to be pointing towards and needs to start addressing, even if we haven't solved all the problems of how do you know where the technical debt is and what it looks like and how much there is. We haven't completely solved that, but still it's time to figure out what we do with that information.
And maybe to piggyback on what Carolyn just said, I think research as well as transition to practice goes through different cycles. There's a cycle plateaus and then jumps. So I don't know whether we've looked at it, but I think the past 10 years of technical debt has probably observed some plateaus and jumps. Like there was a plateau of, I would really defining it at the same way and circling around. And I think once industry really started picking it up, like, yes, we agree, here's actually our experience in technical debt, there was maybe a jump. And now the tool vendors, there's a question I see, there's a confusion of metrics. That's probably where we have the plateau. Everybody is measuring the wrong thing, but somehow somebody will figure out, okay, here's the right thing to measure. if measurement at all is the right approach. And I think that's normal. And the question whether we have solved all the problems is probably not one. These will evolve. It's a discipline. It's going to stay, like requirements engineering, architecture, testing, and we'll actually add practices to it.
Yeah, and you mentioned, Ipek, this question that has been just mentioned from the chat about having different measurement systems that they measure very different things. And the question here, I think you already answered to some extent. Should we actually measure, or how do we measure? But is there some ground research that we are missing to make this measurement a bit more maybe reliable and on the same page, let's say? Otherwise, we are whatever tool we use, we basically get completely different technical debt. What are your thoughts? Maybe Elin, you can, if you have some from the industry side, what do you think about these tools and measurements? And
yeah, I've got sort of two thoughts because I have my research hat on, being a bit of a researcher too, is that it would be good to have probably better agreed on definitions. And my practitioner inner self is screaming at me, don't let them go off and start discussing definitions. They won't come back for 10 years and what they produce will be too complicated for us to use. So I think there's some foundational thinking in industries being done. I'm quite sure it's not rigorous enough, and I'm quite sure that it could be improved. I think that's maybe the role of researchers, is to look at what practitioners have found useful, both in terms of sophistication and focus, and then consider, can it be usefully reified, defined better, inconsistencies pointed out, and so on. I mean, an interesting thing is that quite a lot of tech debt research papers that I read, maybe because I'm biased towards the more quantitative ones, they actually use open source tools like SonarQube for their work. So they're implicitly importing all of SonarQube's view of the world as to what technical debt is. That's another comment. I'm really sorry for anyone who's listening who I've reviewed one of your papers like this, but I always say the same thing, is why are SonarQube's definitions technical debt? And on what, do you understand what it's telling you? Why are those things all technical debt? So I think there is definitely useful work to do there, but what we don't need is an ISO standard and a 47 entity meta model.
Thanks, Erin. Caroline, do you have some thoughts on this as well that you want to share?
Yeah, I do. So I also have concerns about the sonar cubification of technical debt research. It is more prevalent than is healthy, I think. Although on the other hand, SonarQube offers something that we're looking for, and it's a very easy thing to employ. The paper that Zadia was talking about in the chat, I was in that talk too, and the really interesting part that I want to go back and read the paper about is they also took steps towards looking at the things that the tools flag as technical debt. Do they really do the things that we expect technical debt to do in the future? Do they have higher churn? Do those parts of the system have higher churn, more bugs, that sort of thing? And that is an incredibly important, no matter how you measure things on the front end, you really got to figure out which of those things work on the back end and the future. Do these things, do these measures or the anomalous or red colored values of these metrics on the front end, they really correspond to bad things happening, higher maintenance costs later on. And those kinds of studies, I think, are really not as frequent as they need to be. Mm-hmm. Although it's hard to generalize those kinds of things. So I'm not sure exactly how to do those studies, but we need to try. As far as getting tools to agree on measuring basic things like lines of code in the same way, I don't know that they all need to measure it the same way, but they need to publish their definitions, and they need to give the formulation so that people can make a choice. It's like this tool and this tool, they measure it differently, but I see how this one over here is the one that fits my context best, so I'm going to use that and use it consistently. So I don't know that we need to agree on metrics definitions or even tech TD metrics definitions, but we need to be explicit about what we're measuring right down to the low level, because small differences in the formulas and in the algorithms for calculating these make big differences in the results.
Yeah. So in our word, maybe you are saying we should also choose right proxies for technical, for measuring technical. Yes, of course, it's very interesting. And I have another question in my mind. I mean, now we discussed very technical that research, but it was very interesting also to go to decision making, for example. Caroline, you mentioned that, and I was thinking, what other fields can actually help technical debt besides, like you mentioned, decision making? Is there something else that we can boost our studying technical debts? What do you think? Do we need some other expertise maybe in to contribute to technical debt? Maybe Ipek, you can.
Sure.
You have some idea?
So
Yeah.
I don't know whether it's expertise, but I think maybe understanding how a different field evolved and succeeded might help. And this is probably biased from some of the organizations that I have to work with, which is security vulnerabilities is at the top of their concerns. And today, nobody actually pushes back when you say you have to manage your vulnerabilities, you need to be able to use tooling, you need to track it, because there's a lot of risk associated with it. Some of the research there, I think, is similar to how technical debt could be identified, recorded, how organizations could buy into it. So maybe understanding how those might parallel and how some of the research methods might carry over to technical debt management might be helpful. This is a new insight that I had actually in the past couple of months. There's similarities in terms of how defects are managed and securities vulnerabilities are managed and how technical debt would need to be managed. But we know they need to be separately identified. Can we actually take advantage of their similarities in terms of their practices, therefore be able to highlight the differences easier? So that's an area which I personally started to thinking about lately.
Great. Yeah.
Yeah, one that immediately occurs to me is that there's a long history, it's quite a big community around mining software repositories and software analytics. We've actually got he's actually a full professor of computer science at Timisoara, but works for me at Indam as also a full-time principal engineer for us. And it was Radu Marinescu, and he's created amazing tools which we use on client assignments to do software analytics. And he, of course, is building on like 15, 20 years of his personal research, but there's a whole community he used to be part of. It's occurred to me several times that when I read research papers in technical debt, they seem to be trying to achieve many of the same analytical goals, but don't seem to be reusing maybe just out of the box tools, which the analytics community's actually had for quite a long time.
Yeah. Yes, and just to stay there, Owen, I have one more things to ask you. Someone in the chat is mentioning, but this is probably true for a lot of other subdisciplines in software engineering, but it seems to be quite difficult to. Oops, Owen is disappeared. So I have to ask this to.
He agreed to it.
Or he strongly disagreed.
Ask him his data.
Yes, yes. That's okay. I can. Let's
I
wait.
have no idea.
Yeah, you're back. You were really trying to avoid this question, but I was just waiting for you to come back. Sorry. So the question is, don't disappear again. So if from the chat they say it's very difficult to collaborate with companies and getting access to actually trying to understand the technical debt from the trenches in practice. Do you have any recommendation maybe, or how can we study this better in practice from your point of view? What should we do?
That's a great perspective. I think there are two things. One is start from industrial problems. Ask 10 software architects what their problems are with technical debt, and you will have an avalanche of ideas as to what their problems are. From that, you could obviously, as your researchers, you could do a grounded theory study about and actually work out what the problems in the field are likely to be, and obviously make the study as wide as you can. That's one thought, is start from the problems, because I think there's great benefit in working out solid conceptual underpinnings, but I feel that a lot of effort often goes in the wrong direction because it proves not to be terribly useful, because actually the real problem was pointing somewhere else. And the second thing is what we mentioned earlier, which is starting your analytical journey on GitHub's a fantastic thing to do. It's much better than not doing it, but actually generalizing it from there to big enterprise systems is quite flawed. So can you go and talk to one of the large organizations, maybe some of your alumni are now in them, some of your research students might now be employed by them, to say, can we get NDA confidential access to your code bases under very strict conditions where we can do analysis, share it with you, and then we will take some anonymized parts of that away and publish it. And I have read great papers like that where actually they've been in quite large industrial environments and they're very careful about not identifying who it is, and sometimes it's a little bit too anonymous. You can't really tell quite what they did, but there's a balance to be gained, but not revealing the precise company they were working for. I think that's a great thing to be doing. And yeah, I mean, I'd be challenging any software researcher in technical debt of all things that started in industry to be finding companies with representative problems. And on the other end, there's plenty of tiny companies we work with, employ 50 people, and they're burning venture capital money, and they are piling technical debt up day in, day out. They've got very different problems to, say, a large bank that's got 40 years of technical debt. So, I mean, all of these organizations have got, I think, interesting problems.
Yeah, that makes sense. But then just a follow-up question for all the three panelists. So if we study companies, we want to understand how to deal with technical debt. But what if the companies are not mature in working with technical debt? How do we know what actually works rather than just looking at their code? Like you say, okay, we do an NDA, we look at their code, but how can we know that that company is doing it right or not? And how do you go about that?
Well, you don't. That's why it's research, right? Otherwise,
yes,
pick up the.
Yes, but as researchers, we want to have like an environment in which one can try things, not just looking at what's happening.
The other thing that always occurs to me is that there are some very large research-oriented software systems. So in the UK, I think it's now been shut down, but in the early days of cloud computing, there was a massive compute grid was built as a kind of semi-open source project by a fairly sizable team of, if you could call them research software engineers. I think in other fields, they have built quite large pieces of software and maintained them for many years, and they might be very amenable to people talking to you. But are people doing the right things? I think that's almost irrelevant to the research. The research is about establishing what the outcomes were, whether that was the right thing to do at this stage. I think we could collect so much more interesting findings and come up with so many more interesting research questions before we have to really challenge ourselves. Is this the way Google do it, which is the way industrial people approximate correct? What do most companies do? And actually, that in itself is an interesting finding. And maybe from working out what the problem is, what their results are, and what they're doing, you as external, independent, intelligent people could say they're all making the same mistake. And that would be a phenomenal finding.
And Antonia, this all reminds me, sorry, Carolyn.
No, go ahead.
This reminds me, in the earlier days of software architecture research, there were two key observations. Once, whether you apply practices or not, whether you know or not, every system has a software architecture. I think we can just replace software architecture with technical debt. It will be correct. And the other is, just because you apply good practices does not mean you're going to end up with a good architecture. Similarly, just because you're applying good practices does not mean you're going to be able to manage your technical debt. I think that's where, as we talked earlier, the social aspects, the organizational aspects, the business aspects of the system, that's what defines success. And then what generalizable or not, I think requires multiple examples to accumulate.
We're almost out. Just quickly, one problem with technical debt research is there is a big gap between applying practices to see how they work and finding out if they worked, because we're talking about maintenance over long periods of time. And when it's hard to convince people to try something that they're not going to see the benefit of for many, many releases down the road.
Yes, great. I mean, we are 30 seconds from the end of this. So do you have some quick remarks, like 10 seconds each, 5 seconds?
I have one thing to plug, which is there's a fairly new podcast run by my friend Chris Swan and a colleague of his called the Tech Debt Burndown, which they happened to interview me for yesterday. And they're going around industrial people finding out about what they think about technical debt. Maybe some researchers could take part.
Okay, thank you very much, everyone. Thank you. Bye-bye.